All right, guys. So what you are seeing here is the report as well as the spreadsheet that's going to be required for the blood alcohol concentration lab. And this is where we kind of ended up. And it looks like Group A calibration point number 6. And that's the one that we were dissecting and talking about what these numbers and what these values actually mean. So we're going to have to figure out what numbers are going to be dumped into the spreadsheet. And the spreadsheet is what you're seeing over on the left-hand side. Yours might be a little bit prettier. It might be reorganized slightly, but all of the important information is going to be there. It just might be in a different location, or visually it just might look different. So don't freak out if it does. And we need to figure out what goes on and how I input the data. All right, so over here to the left-hand side, you are going to see a spreadsheet template that has been populated for you. And up here at the very top, it says 2024. And underneath 2024, I see Part A, preparation of the stock ethanol standard. All right, so basically what does that mean? Well, all right, so it says mass of the ethanol in milliliters. We used 4 milliliters in the very beginning, if you remember. We took 4 milliliters of ethanol from the jug, and we added that to a volumetric flask. And then that was a mixed standard, give or take a little bit, sooner or later. It had other alcohols that were also there with it. And then we diluted that to the line, and then we diluted it again for another round. So that is where all of that information is going to go up at the very top. Now, 2024's data was based on the lab procedure that they did. So let's look at what they did. It looks like they took 4 milliliters and they put that into a 25 milliliter volumetric flask. And they made a standard. And then it looks like they took 20 milliliters of that, then diluted it to 250 milliliters, and they calculated a percentage based on weight of ethanol in that final solution. Now, your lab prep might not have been the same. It could have, but it could have slightly been different. So there are changes that could happen up here in Part A based on what we did together as a group, not what 2024 did. All right, so with that said, let's figure out what these numbers represent. All right, so 4 milliliters of what came from the super pure absolute jug, 4 milliliters, and then here it says actual mass. All right, so what happened here in that cell is that they took the milliliters and let me just go to a new sheet. All right, so they took the milliliters of ethanol, ETOH, and they were like, okay, this is what we pipetted, and we added this to a solution. But, you know, this calculation is going to be mass-based. So milliliters won't cut it. We need to know, like, okay, well, how many grams of ethanol would that have been? If I took that 4 milliliters and went over to a balance and put that 4 mils onto an analytical balance and weighed it, what would be the mass? What did we actually use gram-wise, not milliliter-wise? So what happens here is that the density of ethanol becomes very important. And density tells you how many grams per milliliter of solution, that's how much that would weigh. So if I did 1 mil of solution of ethanol, the density is, that's the gram of 1 mil. So we need to do a calculation here, but in order to do that, I need the density of ethanol. All right, so the density of ethanol is given in the spreadsheet for you, and that density of ethanol is 0.789 grams. It's right there, 0.789. So in order to set this up the proper way, I'm not going to shortcut you. I'm going to set this up a proper way to get you trained in good technique, good method. All right. So I'm going to take the milliliters of ethanol, which is 4 milliliters, and I'm going to put that over 1. That is how we set these conversions up every single time. We put the given number, 4, over 1 in the very first step, no matter what. In the next step, I'm going to bring in a conversion unit. 4 milliliters on top. Well, let's focus on units before we start plugging numbers in. Milliliter on top. Milliliter is going to go on the bottom. Okay, well, what do we want? Well, we want gram. Can we go to gram? Absolutely. Hello, density, gram per milliliter. All right, well, there's milliliter. I can go to gram, so I'm going to put gram up on top. That's the unit we're after. And the way we go from gram to mill is using density. And I know that the density is 0.789 because the spreadsheet gave it to me. All right, so 0.789 grams per 1 milliliter. That is the proper setup that we call dimensional analysis in order to make this work. All right, so basically what that means, and if you use a little common sense, you would have known this way beforehand, you would take 0.789 and you would multiply by 4 because you're using 4 mils, not 1. So 0.789 times 4, and you will get a number. And that number is grams of ethanol. That is how much 4 milliliters weigh. Now, if you don't like that and it makes you feel comfortable, it's okay. Take 4 and then divide that by 1 and then times that, because that's what that is. That's multiplied by 0.789, then divide that by 1, and you'll get the same answer. What you will realize is that if there's ones here, I just kind of ignore them. I don't do anything with them. And the reason is because when you multiply by 1, it doesn't change the answer. And when you divide by 1, it doesn't change the answer. So whenever there's ones involved, I just leave those out. But that's me. I've done it so long, I feel comfortable with that. If you don't, leave them there. It's not going to hurt anything. 4 divided by 1 times 0.789 divided by 1. You'll get it, I promise. And when you do that calculation, what you'll see is that you will get 3.156 in the top part of that spreadsheet. So that is the amount of gram that we have used in the standard preparation for ethanol. All right, so this group decided to take 4 milliliters and they took it to a volume of 25 in total. So we need to calculate the percentage based on weight. All right, so in order to do that, how did they get that 12.62? So what they did is that they were like, all right, well, this is a percentage. So that 12.682 is the mass of ethanol that was used from that calculation, 3.1560. And they took it to 25 milliliters in total. And 25 milliliters in total, we are going to assume, it is not correct, but it's pretty close. We're going to assume that is 25. Volumetric flasks are not perfect. So I'm just assuming, yep, it was a perfect flask, and you had a perfect day, and your meniscus was perfect. So this is gram on top, and this is milliliter on the bottom. And if I take 3.1560 divided by 25, I'm going to get a value. But this is a percentage. So a percentage is multiplied by 100. And that should give you 12.62 as an answer. All right, so why are we doing this? Well, the legal limit is 0.08%. It is in terms of percentage. Therefore, at some point in time, we're going to have to report our numbers in terms of percentage. And this is the first step in that direction. Now, this was way too strong to analyze. This was way too big to analyze on the machine, and it would just skyrocket our samples extremely high, and the data doesn't make any sense. So we got to weaken that down. And we did that together as a group. We might have done it a different way. Go back and take a look at the procedure and how we did it, but we weakened it down in some form or fashion. So what this particular group in 2024 did is that they were like, oh, well, okay, if that's too strong, I'm going to take 20 milliliters and I'm going to take it to a total volume of 250 milliliters. I'm going to dilute it down that way. What is the new concentration after that point? All right, well, the dilution equation is MV equals MV. This is dilution. So when I do dilution, I'm going to be like, okay, these are my initials and these are my finals. Some people use F's and I's and some people use 1's and 2's. Doesn't matter. The first M, well, that stands for molarity, but we don't have molarity. We have percentage. Can it still work? Absolutely, it can still work, because really the dilution equation is CV equals CV, where these are 1's and 2's or I's and F's. That means any concentration will work, no matter what it is. Any concentration will work. I don't care what it is. Trust me, done it long enough. So in this dilution equation, we start off with a 12.62%. Now, I'm not going to change that to a percentage. I'm just going to put 12.62 because it will work. Trust me. And the volume of that, how much did we take? Well, the lab procedure for this group said take 20 milliliters of that. All right, so 20 milliliters of that. So 20 is going to go there. Equals, what is the new concentration that we have made? Yay! All right, well, we're trying to solve for that. So that stays as C. That's my final concentration. Okay, well, how much in total did you make? Well, based on these directions that this group did, they made 250 mils in total. All right, so 250 mils in total. As long as the units work the same on both sides, the equation is fine. Meaning 12.62 is percentage. And my answer, because of that, will be in percentage. That's fine. That's what I want. The 20 is in milliliter, and the 250 is in milliliter. The units match. They work. So I'm going to take 12.62 times 20, get a number, hit enter on your calculator. And then I'm going to divide by 250. And the reason is because that's C times 250, and the opposite of multiplication is division. That's how we get rid of that number, because we want C by itself. That is our concentration value. So 12.62 times 20, hit enter, keep all of that together up on top, please. Do this in individual steps. If not, your calculator might lie. And then we're going to divide by 250 in the second step, and we get an answer. And what we get, or what this group got, was 1.01. That is the concentration of the standard that we are going to be using in the sample prep for 2024. Now, once more, your volume might be different. You might not have used 4 mils. Watch the video, it will tell you. You might not diluted it to 25 milliliters in the beginning. If you didn't, okay, not a big deal. Nobody says that you got to do it that way. It might be something totally different. And if it is, use that number. You got this. I have faith in you. I know you can do it. Maybe you didn't do another 20 to 250 mil dilution. If you didn't, you leave it out. If you did, but it was different, you put the numbers that we used in there. Maybe it wasn't 20 mils. Maybe it was 10 mils instead. Maybe it wasn't 250 mils. Maybe it was 100 mils instead. Again, your video will tell you that information on how we prepped these standards. And then finally, the last part for A is something that we call the retention time identifiers for ethanol and for your internal standard, which is propanol. Once again, this is coming from the report that you see over here on the right-hand side. That report is going to be very messy, a lot of peaks that are there. You will be very uncomfortable trying to pick out which one is which. So we got to give you a little insight to this. And what we do is that we run ethanol only into the machine, and we get an identifier. We run propanol only in the machine, and we identify that one. And whatever those times are, I will list them here for you in the spreadsheet so that you will have those for reference. So that way, when you go to these reports, you'll know, oh, well, that's my ethanol 5.593 because they told me that. And there's my propanol at 7.951 because they told me that too. And those are the numbers I'm going to use for this page of the spreadsheet. It's great. That's why we do that. So once more, those times can change from year to year. It might not be 5.5 when we ran them. It might not be 7.9 when we run them. Whatever the case is, those could be different. And that's okay. They're not meant to be the same every single time. We could go in and try to change some settings and try to make this a little bit better. So those values we will provide you in Part A of the spreadsheet template that you'll receive. All right, so there's Part A of the spreadsheet. In the next video, we'll talk about Part B. And for Part B, it looks like a lot. Look at all of those numbers down there. Ah! But a lot of that is looking at the reports and filling in the values of where they need to go. That's what we'll start with first.